In this video, I want to introduce people to time series forecasting for the purposes of this class. And when we talk about what is forecasting, we're putting forecasting in a very specific meaning for the purposes of this class. So a forecast is a quantitative prediction about the value of a future random variable. And we've already spent a fair amount of time discussing random variables in this class. So we first started the class out by describing how random variables can be described if we know all of the possible outcomes and we know the probabilities associated with those outcomes. We found the mean, we found the variance, we found the covariance, we used the law of iterated expectations to uncover the expected value of one random variable conditional on another random variable. We estimated a regression, which is a conditional expectation function of the mean of a random variable given values of x. And so we've analyzed random variables within the context of cross-sectional analysis. And when you take econometrics, you'll do more of this, but now what we're doing is treating the class as a pure time series forecasting exercise and instead analyzing a time series. And so if you think of why this is important, many of you are going to go directly into the workforce after graduating from UWG. And as a consequence, you may obtain a managerial position in an organization that requires you to make a forecast. This is a doable task, but it would behoove you to have some type of systematic process in order to make a forecast. So ideally, from this last half of class, what we can learn is I'm going to look through the time series data that I have, and I'm going to analyze different patterns associated with it, and then I'm going to pick a technique that most closely resembles the patterns that I see up to this point in time to predict the future value of a variable in the future. And we're primarily going to focus on methods that involve using past values of that random variable in some way to forecast the future value of the random variable. But let's just think back about the importance of forecasting to a business more generally. So think of a supply chain. You have suppliers of raw materials, and those individuals interact with producers of finished goods who allocate those goods to distributors. Now, that could be a retailer such as Target, or it could be a wholesaler. And then you have those individuals sell the finished goods to consumers. And so, from start to finish, you have a chain of entities associated with the production, distribution, and sale of a product. Now, suppliers of raw materials do not have data on consumers. They have data on the conditions associated with producing the raw material, and they may get some information from producers about future orders, but they don't generally have information on consumers. So you think of a company that produces thread. The thread is used by apparel manufacturers to produce clothing. Clothing orders are, you could have direct to consumer, or you could have a company like Belk order clothing from the manufacturer, and Belk has the data on the consumer, but the thread manufacturer doesn't have the data on the consumer from Belk. And so distributors have a responsibility to communicate what they learn about consumers to producers quickly. So if I see demand rising for a particular product, it's my responsibility as a retailer or wholesaler to get my orders in quickly and to maybe even pick up the phone and call the producer and say, hey, this is something we're seeing on the ground level. And there are reasons for doing this. So, you could think on one extreme, substitution. If there are goods that have fallen out of favor with consumers, as a retailer, I want to slow down the orders of those inventories so I don't end up holding a lot of inventory. And I may want to communicate to the producer that, hey, consumers don't want to buy summer apparel anymore. What they're looking for is something that's more fall, more winter, or consumers don't want to buy an energy bar anymore. They want to buy an energy drink instead. And that information is important because all the feedback that the producer is receiving is from the distributor. They don't have the direct. So Body Armor doesn't have direct purchases of my brother-in-law who likes to drink Body Armor. He doesn't. The company doesn't observe his preferences. So they have to be in communication with this intermediary in the supply chain, the distributor. And they have to communicate up the supply chain to the supplier. So there are also costs of not having product on hand, and these are kind of more readily observable. You could think of going online to purchase apparel and not having your size. It's called a stock out, and I'm just a lost customer. So I've gone online frequently to look for clothing, and sometimes I'm successful and sometimes I'm not successful in purchasing what I would like. But when I'm not successful, I don't often think, hey, I'm going to go back to this website later to see if it's in stock. And I also don't like to check the box, hey, notify me when it's in stock. If I'm out looking to buy something, I'm looking to buy it right now, and I don't have time to wait for the supply chain to reorganize. So stockouts are costly and partially preventable by having higher quality forecasts. And so businesses have incentives to share forecasts for many reasons. You can think of fewer rush deliveries. So if you've ever had to next day air anything to anyone, that's extremely costly. You can think of better timing for sales. So grocery stores are quite privy to information associated with consumers, and they have well integrated supply chains. So they know, hey, when the Super Bowl is coming, we want to have chips on sale. We want to have hot dogs on sale, hamburgers on sale, soda on sale. Put it all on sale. We know we're going to see this huge surge from customers based on previous data that we've observed. Lower inventory and capacity buffers. So you think of companies trying to become more lean. One way of doing that is having a much more refined inventory control. So I think if you look at some of the patterns associated with businesses that have failed in the last decade, if you look at the downfall of like department stores, they just held way too much inventory for way too long. And when you compare the success of a department store to the success of a smaller retail store, smaller retail stores hold a smaller variety of products, but they also hold those variety of products for far less time. So, lowering your inventory buffer can be a way to lower your costs, but that's a result of a good forecast. Think of capacity buffers in the same way. And so the objective for this class is to try to predict the future value of a random variable as accurately as possible. And we're going to try to do it via any reasonable means necessary. So if you think of regression, it's very predefined what you need to do to compare two variables or two or more variables to each other. But with forecasting, it's not necessarily the case. So we actually have a wide variety of options for dealing with our data in order to make an accurate forecast. We want to distinguish forecasting from goals and planning. So in an organization, whether it's a business or otherwise, there are things that you would like to have happen. And so for the University of West Georgia, we would like to increase student retention. We want students who start here to stay, and we want them to graduate more quickly. That is a goal, okay? It may not happen. That is possibly communicated from a forecast. So it's really important to segment our predictions from what we would like to see happen. So I think you don't want to pick too much on this, but we have a goal of having the lowest COVID-19 positive rate as possible. The data that we're collecting right now and the forecast that you could make associated with that data, the data that we're collecting is not very good. And the forecasting methods we're using are non-existent. So we're not trying to execute our goal based on any forecast, which is a problem. Now, planning is how you execute the goal. So it's the course of action you have to take to achieve the goal based on the forecast. But that last part is really important, based on the forecast. So, the outcomes are ultimately uncertain, but you try to predict the outcome based on the best information that you have. And so oftentimes goals are chosen without any reference to a forecast or plans. And this is where forecasting is really something that we should take seriously if we're an entrepreneur or if we're part of a business. We need to take this notion that there needs to be a tie to the forecast in order to achieve the goal. There are three types of forecast durations that we may be interested in. There's a short-term forecast, which you would need for personnel, production, transportation. This is the most familiar forecast that you have, something you've done previously. So if you work for a business where they're trying to predict how many employees come in, that's a short-term forecast. You can think of a medium-term forecast, like a forward contract for like jet fuel. And that is something where the duration is a little bit longer, but we're trying to contract for materials that we might need in the future. So we need to forecast those materials, and the future may be 6+ months. A long-term forecast, look, we have strategic goals for the College of Business. That's a 5-year plan. The forecast is quite a lot longer duration. So if you're thinking of expanding capacity, via a long-term forecast. So let's talk about what needs to be forecast. Should we forecast all product lines? Some product lines. Do we forecast all sales outlets? Some sales outlets. Do we do it at the weekly level, the monthly level, the annual level? The answers to those questions are organization specific. However, the questions themselves are ones that need to be asked. So it probably isn't that necessary for Kroger to have a forecast of sales for every single product that's on their shelf. A lot of the products that are on the shelf are managed by vendors who come into the grocery store, stock the product themselves, and the vendor is the one that is responsible for the forecast, not the grocery store. So, Kroger may not need to forecast every individual variety of beer so accurately when the beer is being distributed by a vendor that's keeping track and managing inventory for the grocery store. However, Kroger is going to be on the hook for the produce and the meat and the baked goods and many of the other products that they stock, cereals, So you can think of this as just being an example of it is probably somebody's responsibility to have the forecast for consumer demand for these product lines. However, it may not be that organization. Do you do all sales outlets? Do you do some sales outlets? That's another type of question. Does Dollar General have intricate forecasts for every Dollar General that it has? It probably has some forecasts, but a lot of Dollar Generals have really, really high margins, so the behavior is not going to be too different. Other things that we need to think about when making a forecast, the duration of the forecast, that's going to dictate the model. So are we forecasting a short-term, medium, or long-term? That's going to be dictated in part by the model that we choose. Frequent forecasts. So maybe we should think of using a prepackaged software that implements a standard method if we're going to make a forecast every day for something that's very similar to the previous day. That's what a lot of organizations do, but there are instances where this isn't desirable, and we'll talk about some of those now. So this class is going to focus on quantitative forecasting techniques. And if you look at the Heinemann book, the quantitative forecasting techniques are from chapters 2 through 5 and chapter 7 up. Chapter 6, however, talks about what's called qualitative forecasting. And so rather than leaving it to Chapter 6, where I feel like it's a little bit out of order, we're going to talk about it right now. So we may need to make a qualitative forecast. It is not a pure guess. So qualitative forecasting is important for a few reasons. First, some problems have no data available to them. And then second, some data that are available may not be relevant to a forecasting technique. So there are data limitations that may lead us to make a qualitative forecast where we're not implementing a quantitative model. However, there are still objective ways to make this qualitative forecast. And so these are often called judgment forecasts, and you may not have any quantitative experience in your current setting. So how is this new competitor going to behave? Well, we've never seen the competitor before. How is this new product going to be received? Well, we've never seen it. What is GDP right now? Well, the data are available after delay, but we're making a decision based on what we think it is right now. That's a qualitative forecast. Accuracy of these qualitative forecasts can be improved, and there are a couple of ways that can be improved. First, if you have up-to-date information, you've got to have the most up-to-date information about everything else in the institutional environment possible. So in order to assess the validity of a new competitor, I should have as much information as possible about how previous competitors have behaved, how things are going for us right now. Any excess capacity that we might have, will that be amplified? Or will we be taking away business from customers that are already there? And then domain knowledge. So if the forecaster is well experienced with similar types of decisions or has deep knowledge of what has happened in the past with this organization, the accuracy of the forecast is going to improve. And so, you kind of think about this as talking to a senior colleague. So you may be facing a new problem. The senior colleague may also be facing a new problem, but the senior colleague probably has a better ability to classify the seriousness of the problem because they faced problems that, even though they're dissimilar, they can tell the reaction might be deeper or greater in the past than it is right now. And so they can put some structure on the scope of the problem, which will be very helpful in making a forecast. Still, we should think of qualitative forecasting, despite there being some ambiguity as far as a lack of data. It's a science with systematic methods. And so there are some principles we want to employ when making a qualitative forecast. The first principle is to set the task concisely and clearly. Okay, so be very clear as to what you're trying to forecast. For example, we're offering a new product this quarter. What are sales for this new product going to be? Maybe we don't project it out to overall sales for every product that we offer. We're just looking at one product. Or maybe we don't want to try to forecast, is there going to be higher demand for this product on Saturday or Sunday, or is there going to be a surge after product experience, after customers learn how the product works, are they going to like it more? Maybe we just want to try to focus on something like, what will sales be? That's a concise task. It's very clear what it is. You're not trying to add dimensionality to the problem by focusing on assorted details. The next principle you want to have is to implement a systematic approach. So think of it as kind of predefining what you're going to do when. The third thing you want to do is document what you did and justify it. This is really a type of strategy that you should have, even if you're not making a forecast, if you're trying to solve any problem. Write down what it is that you chose to do and why you chose to do it. The fourth step is to systematically evaluate the quality of the forecast. So the minute you get data, you should see how you did. And you may want to go and identify and it does speak back to the document and justify. So for example, if I have an aggressive prediction for sales of a product and we don't hit that benchmark, then I immediately know that by comparing the forecast to the actual data. So I can look at the error immediately. However, I may also need to go back and look at the documented justification for the high forecast and assess whether or not it's reasonable to think that the assumptions I used to, or maybe assumptions is a bad word, but both the assumptions and the information that I used to make that forecast, are those two objects as strong as I thought they were. So I assume that there are going to be high sales of this product. However, I didn't realize that this was a low volume month, or I didn't plan for a reduction in income or something like that. The last thing we want to try to do is segregate the forecasters from the user. Segregate is not a bad word. We're trying to keep them apart. So I may be the user of the product. I may be the salesperson or the person who wants to see the goal or the plan implemented. So I want to try to de-bias any of that by just keeping the forecast separate. So at like a macro level, even outside of forecasting, it's usually a pretty good idea to try to segment what you think will happen from what you want to happen. So I try as hard as possible to make decisions based on what I think will happen, not based on what I think I want to happen. And I think that's a skill set that you want to employ as, an economics major or even somebody taking this class. It's like one of the key hallmarks of the discipline is to be able to segment what you think will happen from what you want to happen and act accordingly. And so producing what you think will happen, that's a forecast, but we want to keep that production separate from what other people want to have happen. Okay, so there is a kind of tried method for making a qualitative forecast. It's described in the book. It's called the Delphi Method. The Delphi Method relies on an assumption that a group of forecasters is more accurate than individuals. And so there's a facilitator of the method who assembles an anonymous panel of experts. And the goal is to get quite a bit of diversity in the skill set. So you may have somebody who's a very skilled technical forecaster, but has limited institutional knowledge. You may have somebody with deep institutional knowledge who's not accustomed to making forecasts. You may have a manager who's somewhere in between. You may bring in a consultant. Whatever the case may be, you have a panel of people with different domain knowledge that can produce a forecast. And so you set the task and distribute it to each of these experts. It may not be the same thing. So if we have like kind of a composite forecast where the success of the product deals not just with the product itself, but with overarching economic conditions, then you probably want to have somebody who is a macroeconomist forecaster forecasting the macroeconomic conditions separately from anybody with institutional knowledge of how products received or domain-specific knowledge about that particular product. That person is not going to be qualified to assess the macroeconomic conditions, so you want to bring in a different expert. And so the experts will return their forecast, they'll return the justifications, they're going to be compiled and summarized, and then feedback will be provided to the experts. So if there's some uncertainty in the forecast based on something in which another expert has domain knowledge, that uncertainty could be resolved in this step of the Delphi method, where you've got expertise that is in one domain now being disseminated to different domains. They update their belief based on the information that they receive, and you're going to update your forecast. Forecast is an announcement of the belief. And then final forecasts are constructed. So ultimately, we're going to figure out how to weigh each expert's forecast and produce a composite based on that. There are some other types of forecasting methods that we can look at. I just want to focus on forecasting by analogy, new product forecasting, new scenario forecasting. Forecasting by analogy is kind of a dangerous forecasting method because oftentimes there's just one analogy being used. So, whenever we're kind of adopting a method of X is like Y, it does offer up the possibility of stereotyping or bias in that regard. So ideally, if we're forecasting by analogy, we want to try to think of multiple analogies that could be produced and aggregate those analogies rather than just going on one analogy. So you think of appraisal. Why do you seek out three houses? Well, it's because, there may be a bad analogy with any one of the particular houses. They may not actually be all that comparable. With new product forecasting, there are multiple relevant constituents. So you think of customers, you think of the sales force, you think of executive opinion. All of those people matter with the new product forecasting. There are advantages and disadvantages to each, but if you think of using customers often don't do what they say they will. So I've told people many times I'm going to buy a product to get them to leave me alone, and that is a hallmark feature of being a customer. If you think of the sales force, you don't make money if you don't sell, so you need to have something to sell. Therein lies the problem. You have a moral hazard problem there. And executive opinion is kind of the same way. So all of these are methods of qualitative forecasting that we want to at least consider if we have no data available. If we have no data available and the stakes are large enough, you really need to consider a detailed method like the ones proposed here. So let's talk a little bit about quantitative forecasting. What's the idea behind quantitative forecasting? We're going to pretend that Y is the quantitative variable of interest and that we've observed Y in every period of time in the past. So Y is what I'm interested in. I've seen it a lot. The only information we have is data from today and the past, or you could even think of, if you don't want to think of having today's data, then the previous period and all previous periods to that. The indexing of the time period is with T. So T indexes the time period. The time period could be down to the second. It could be hourly data, daily data, weekly data, quarterly, monthly, year data. But T is just a description of the periodicity of the data set. Y is the data. Y hat is the forecast. So you may also have some variables from the past like xt minus 1, xt minus 2, etc. But we're going to start by just using methods that only focus on combinations of previous Y to predict the current Y. Or a future Y, like period T plus 1, that's in the future. Or even T plus K, where K is many periods into the future. So, we're going to start by thinking of all of these as being kind of short-term forecasts, but, we can expand into medium and long-term forecasts as well. So let's take a look at the timeline for quantitative forecasting. Time goes from the past to the future, left to right. So period T is the current period, okay? And prior to period T, you observe data in periods T minus 1 and T minus 2. Prior to period T minus 1, you observe data from T minus 2. You can use that data along with any data that's in the past to forecast T minus 1. And you can forecast T and T plus 1 as well. Those are longer term forecasts, but the only information you have to produce it with is everything prior to T minus 1, so the T minus 2. So you make the forecast, you observe the data in T minus 1, and now I have additional data with which to make my forecast, T minus 1 and T minus 2. Take that information, use it to make a forecast. Now I have additional information from the past, T minus 1, T minus 2, and I can use that to forecast T plus 1. Additional information should be incorporated into the forecast if it's at all relevant. implement. So once you learn something new, you know something new. That's a big deal. Some additional complications that we might think to have is that we assume that each underlying data set has something systematic about how the data are produced. And so we don't actually know what this process is. But we're going to try to learn about it by producing graphs, maybe decomposing the time series in some way, take additional steps to uncover what the process is that generates the data. And it may not be like a predefined function that generates the data. Obviously, that's probably a little bit of a stretch. However, we can at least get some clues about the process from examining how close our forecasts are to the actual data and how much our forecasts miss the actual data by. They're not the same thing. So the size of the miss is one, the number of misses is another. We look at both. And we're likely to miss. Okay, so we're going to take a look at two quick models of forecasting and call it quits for this video. These are baseline models for future analysis. So the first is what's called the naive model. My forecast for today, or the current period, YT, has the immediate previous period, YT minus 1. Then there's the average model. My forecast for today is a combination of previous periods in the past. So my forecast for today, YT hat, is 1 over n times the sum of previous periods that I'm interested in, YT minus 1, YT minus 2, all the way to YT minus n. These are periods from the past. So this model is going to use an equal weight of previous periods to forecast the current period. We call it the average model. This is often, if you go to work for a business, they'll call it the moving average model, and that's fine. It is a moving average. I think in forecasting, sometimes moving average tends to mean something else. And so we're going to stick to that definition in this class and just call this the average model. So the next slide is going to use the naive, the 2-period, and the 3-period averages to forecast the share price of Southern Company. Southern Company is an electric company that owns both Georgia and Alabama Power. Okay, so here are some data. This is the close price for Southern Company, and you can see it's kind of hanging out in the 58 to 60 range. This is for about a month. Okay, so the naive forecast is the third column. Presuming that the first data that I observed was October the 8th and that I did not observe October 7th, I can't make a forecast using the naive model, nor can I make a forecast using the 2-period average because I didn't observe that data either, or the 3-period average. Now, I can make a naive forecast for October 9th. That forecast is 58.71. And what we want to think of doing is to hide the data from the current period when forecasting the current period. So the current period is 58.74. That is unknown at the time of the forecast. And it's a very important conceptual point. So there is no need to forecast data that you know. Now, the 2-period average would require me to use October the 8th data, which I have. But that only counts for 50% of the forecast. The other counts from October the 7th, which I don't have. So I can't do a 2-period average, and for the same reason, I can't do a 3-period average either. For October 12th, I have the naive model. I have a forecast of 58.74. For the 2-period moving average model, I have a forecast of 58.725. How it works is we add 58.71 to 58.74. That yields 117.45. Divided by 2, 58.725. Okay, so we're just averaging, and it's going to be right in the middle of these two data points. And the same deal for the 3-period. We have October 9th. That would be a third of the forecast. We have October 8th. That would be an additional third, but we do not have October the 7th. So again, we can't do a 3-period forecast here because we don't have 3 previous periods. We just have 2. So for October 13th, the naive forecast is 58.86. The 2-period average is the average of 58.74 and 58.86. Those are the two most immediate previous prices. It's right in the middle, 58.8. The 3-period average, you take 58.71. You add 58.74. You add 58.86. So you have I think that's 176.31. You divide it by 3, you get 58.77. And that is the 3-period average forecast. So we just keep doing this as we go forward. Now, I want to point out at the end that we do not know October 27th data yet. The close price is unknown, so the naive forecast predicts 60.11. The 2-period predicts right in the middle of 60.85 and 60.11, which is 120.96 divided by 2. That's 60.48. And the 3-period moving average takes the 60.56, the 60.85, the 60.11. So we add that all up, we would get 181.52 divided by 3, 60.5067. So all of the forecasts for October the 20th are predicting something that's in the 60s. And depending on how much information we include from the past, they predict different things. So the naive, the 2-period, the 3-period, think of these as just being very simple baseline models of forecasting that we can do to kind of, let's just say we were to do something simple. What would that look like? What would the amount of the error be? Does this suffice for our purposes? It does? Okay, that sounds good. If it doesn't, which it often won't, then we need to do something else, and we're going to look into what those something else's might be.